Review questions, part 1, starting with number 1 on page 180. Question 1, can the speed of an object change if the net work done on the object is 0? Can speed change if net work is 0? Well, if we look at this equation here, if work equals 0, that means there is 0 change in kinetic energy. If there's no change in kinetic energy, that means the speed is most likely going to be unchanged. Therefore, the answer would be no. The speed of an object cannot change if the net work done is 0. Number 2, discuss whether any work is being done with each of the following agents. If so, whether the work is positive or negative. So, number 1, letter A. A chicken scratching the ground. The chicken is definitely doing work on the dirt. The chicken's foot is applying a force to the dirt. That force is directed backwards, and the dirt is moving backwards. Those two directions agree. It's going to be positive work. A person reads a sign. No work. C. A crane lifts a bucket of concrete. Yes. The crane is going to be lifting upward. The bucket of concrete is going to go upward. So that's positive work. Letter D. The force of gravity on that bucket. Yes, there will be work done. There is a force. There is a displacement of the object. They happen to be in opposite directions, so that's going to be a negative work. Number 3. Furniture movers wish to load a truck using a ramp from the ground to the rear of the truck. One of the movers claims that it is less work if the ramp's length was increased, reducing the angle with the horizon. Is that claim valid? So just an image to help with this. If I have the back of the truck here, it's the back of the truck, here's the wheel, right? And we're saying one person claims that having the ramp be here and having the ramp be here, assuming I have them on level ground. The one guy is claiming that the longer ramp is less work. Hate to break it to you, it's untrue. Because for the angle difference, you know, we talked about how work is force times distance times the cosine of that angle. For the decrease in the angle that you get, the increase in the angle here, it consequently goes right with the whole idea of the ramp getting longer and you get more distance but a lesser angle. It's not less work. It's actually the exact same work. Given time, we would have ran up the stairs and the power. Well, power being work divided by time and mass times acceleration times distance. It doesn't matter how we go up those stairs. We're still going vertically 2 meters up the stairs, and it just doesn't matter. We're going this high up. It's the same amount of work. It's easier, perhaps, to use the flatter ramp because you use less force, but you're going a longer distance. Here you'd use more force, but it's less distance. My bad. Moving on to number 5. Drivers of two identical cars head towards each other, applying brakes at the same instant. The skid marks of one car are twice as long as the skid marks on the other vehicle. Assuming that the brakes of both cars apply the same force, what conclusion can you draw about the motion of the cars? Well, if the one car's skid marks are longer, that means it took more work to stop the car. More work, if it's the same force, would have to be more distance. So the skid mark with longer skid marks, or the car with longer skid marks, had to have been going faster for that to work out. Because the work done would equal change in kinetic energy, so you'd need more distance to get the same skid marks, or to get, for the velocity. So longer skid marks are going to mean higher velocity. And that is a police work kind of question. Number 6. When a punter kicks a football, is he doing work on the ball when his toe is in contact with the ball? Absolutely. His foot is touching it. His foot is applying a force to it. His foot is moving the ball a certain distance. Is he doing work after the ball loses contact with his toe? No. The work has been done by the punter. Are there any forces doing work on the ball while it is in flight? Well, sure. Air resistance and gravity. But no more of it being the punter.